So in chapter 17, guys, we talked about kinetics of a rigid body, and we started the first part in finding the moment of inertia. I don't know if you went back to the videos of statics and saw the area moment of inertia. It is in fact the same concept, except here we have a mass moment of inertia. So instead of multiplying the radius squared by area, we have to multiply it by m, by the mass. And as I said in the video lecture, guys, we're going to use these two in order to find the mass moment of inertia for the entire mass. So I advise you guys to memorize these two, to memorize their moment of inertia, because we're going to use them, as you can see now in the first example. So if I start with the first example here, I have a paraboloid that is formed by revolving the shaded area around the x-axis. So guys, if you draw this shaded area on SolidWorks and you do a revolve around the x-axis prime, we're going to have this shape. I need to determine the radius of gyration kx. Now, why is it kx, not ky or kz or k? Because in fact, guys, the radius of gyration depends on the axis, because it's equal to what? It's equal to kx is equal to radical ix over m. All right, so if it is ky, then it will be different. It will be radical of iy over m, kz radical of iz over m. All right, so here the question is to determine the radius of gyration kx, knowing that the density of this material rho is equal to 5 milligrams per meter cube. Okay, guys? Now, what do you think, guys? How to start? I have to start by indicating a differential volume. All right, so I have to start, guys, by indicating a differential volume, and then if I do the integration of this differential volume, I have to have this shape here. Okay, so what do you think? What could be this differential volume? What could be this differential volume? I can take what? Yes, Batul, I can take a thin disk. All right. Now, what is the thickness of this thin disk? It is dx. So why is it dx and not dy? Because in fact, it is in the direction of x. So this is how you can know the differential lengths. All right. So since this thickness is in the direction of x, so it is called dx and not dy. All right, guys. Now, if I take this thin disk and do the integration between x is equal to 0 and x is equal to 200, I can have this entire shape. So if you can take, guys, this view right here, if you can take this view, you're going to see a disk. And what I have to do is to find the moment of inertia around the center of the disk perpendicular to this disk, all right? So I need to find the moment of inertia around xx prime. Now, guys, if you remember, I know the moment of inertia of this differential mass dm. If you go back to this table that I advise you to memorize, guys, here, if I have a thin circular disk, then I, with respect to zz, which is the axis perpendicular to the disk passing through G, is equal to half m/r squared. Now, why I have to use this izz and not this ixx, although I have to find ix in my problem? Because in fact, guys, in my problem, my x is this z here. All right? So in my problem, guys, if you go back to the problem, my x is this z here. All right? So here, guys, if you take this view, this is the disk, and this is xx prime, which means x here is z there. All right, so guys, don't be confused. I cannot use this ixx because x here is different than x in my example. In my example, my x-axis is z here. It's perpendicular to the disk. So I have to use this half m/r squared. Right? So dix of this thin differential volume is equal to half dm/r squared. I cannot say it's half m because this is here my differential volume, so it is half dm r squared. Now, what is r squared here? It's in fact what? What is r squared here? It's in fact y squared, guys. So this is the radius of this thin plate or of this thin disk. All right, so it is y squared, and in fact, I know that y squared is 50x. But I don't know the equation of dm. I have to find this equation. How to find this equation? What is dm? dm is equal to rho dv. Are you listening, guys? All right. And what is v? What is dv here? dv is always the area times the thickness. Now the area here is pi r squared, and I know that r squared is y squared times the thickness, which is dx. Okay, so I know dix, guys. I know the equation of dix. What I should do now is to make the integration to find ix. Ix is the integration of dix. All right, guys. So it's very easy. If you know dix from the standard or the memorized shapes, you can find ix by doing the integration. So it is the integration of rho, which is constant, times pi, which is also constant, times y squared, or yes, times y squared. So I'm writing the equation of dm times dx, and then so this is half dm, and then times y squared, another y squared. All right, which means it is the integration of rho, which is also constant, pi y4 dx. Now, guys, I should know the equation of y in terms of x. Otherwise, I cannot do the integration. And I cannot say that y is constant with respect to x. As you can see, guys, y differs with respect to x. So for each x, I have a different y. And this y, in fact, is equal to, or this y squared is equal to 50x. So since y squared is equal to 50x, then y4 will be equal to 50x squared. All right? So it is half rho pi 50 squared integration of x squared dx, and don't forget that this x is going from 0 to 200. If this y-axis is here at the middle point of this paraboloid, then I have to take x from minus 100 to plus 100. Now here, since it starts from origin, it is between 0 and 200, right? So it is between 0 and 200. So what is the integration of x squared? It's x3 over 3, and then the answer here will be half rho pi 50 squared times 200 cubic over 3. All right, guys. Now, am I done? In fact, no, because I need to find also the mass. And what is the mass? The mass is, in fact, the integration of dm. All right, so it is the integration of half of, no, dm is rho pi y squared dx, so rho pi y squared dx, and I know that y squared is 50x between 0 and 200, which means m is equal to rho pi 50 x squared over 2, because y in fact is 50, y squared is 50x, so the integration of x is x squared over 2, which means it is 200 squared over 2. Now, guys, the final step is to find kx. So kx, let's find kx squared. Kx squared is equal to ix over m. And I know that ix is 1 over 6 rho pi 50 squared 200 to the power 3 over rho, or over 1 over 2 rho pi 50 200 squared. All right, so if you do the simplification now, you can have the answer. So I still have 150 here and 200 here. And this means, guys, that kx squared will be equal to 1 over 3, 50 times 200. And then, guys, you can find kx by doing the integration. I think I have the value. So kx is the integration, the square root of 50 times 200 over 3, which means it is 57.7 millimeters. Okay, any questions? Batul, could you please repeat how we find x squared? How we find x squared? What x squared do you mean, Batul? Second line here? Here? No. You mean the boundaries of x? The boundaries of x? All right. You can see here from this figure that x, this is x, all right? This is x. X is going from 0, the origin, till 200. It's given in the figure. Okay? All right. Guys, any other question?